Hi everyone, welcome to another session of Mr. Techpathy Tutorials. This is part 6 of Linux device drivers. In this session, we are going to discuss about loading, listing and unloading kernel modules. Our first topic will be loading kernel modules, followed by listing kernel modules and unloading kernel modules. Before going ahead with these topics, I strongly recommend you to watch my earlier videos on Linux device drivers. Let's start with the first topic, loading kernel modules. In earlier sessions, Linux Device Driver Part 5, we learned how to build a sample Hello World Linux kernel module. In this session, we will see how to load that sample module into the kernel. We have two kernel utilities which does this trick of loading kernel modules into the kernel. One is insmode, the other is modeprobe. In following slides, we will discuss about these utilities, their syntax and their usage. So, what is insmode and what does it do? Insmode is the kernel utility that installs loadable kernel modules into kernel. It actually loads the module code and data into the kernel land. It links any unresolved symbol in the module to the symbol table of the kernel. Insmode accepts a number of command line options. It can also assign a value to a parameter in a module before linking it to the current kernel. Note that if a module is correctly designed, it can be configured at load time by passing arguments to insmode. Now let's see the syntax of insmode. The syntax is very simple. It's insmode followed by file name followed by module options. For example, here I have insmode mymodule.kvo. This command inserts a module by name my underscore module into kernel with no module options. Second example is insmode path to mymodule.kvo followed by a parameter assignment. It's param1 is equal to 0x330. This command inserts my underscore module.kvo into the kernel specifying the module options param1 is equal to 330. Module options are just like command line arguments to kernel object. We'll discuss more about the module options in upcoming sessions. One important point with insmode is that insmode always accepts one file name at a time while insmoding a particular kernel module. Here I am in a Linux terminal where we have already implemented our Linux device drivers module. So let's see how insmode works. Here we have a sample program which we have implemented in Linux device drivers part 5. So if you can see, we have hello.kvo here, which is a kernel loadable module. So we'll try to insmode this module. What I'll do is, as per the syntax we learned, it's insmode hello.kvo. So as you can see, we are not sure whether the module has insmoded or not. So to know that, we need to execute a command called dmessage. Dmessage, if you see, this is the message which will get displayed whenever the init function of the module is called by the insmode. If you see hello.c, so the hello.init will be called whenever we insmode the kernel object. So this is the message which we will be expecting from dmessage. As you can see from dmessage, when I type dmessage after insmoding my kernel module, we have something like hello world, which is nothing but the one which we have here. So this is the way how the insmode works. Coming to our second utility, it's modeprobe. What exactly is a modeprobe? It's a Linux utility which offers more features than basic insmode utility. When compared to insmode, modeprobe has various advantages. Advantages like it has the ability to decide which module to load. Modeprobe maintains a directory for all the modules. It's under /lib modules and the uname minus "-r" with a dollar symbol. Here $uname minus "-r" is a generic command which is used for retrieving your Linux version. In a terminal, if you type uname minus "-r", you can see what exactly your Linux version is. The second advantage is it's aware of the module dependencies. To know more details of dependencies, modeprobe uses another configuration file which is called module.dep, which sits under /etc directory, which is again generated by dep mode program. There are many. Modeprobe is really a big program where we can discuss. We can have a separate session for this. So let's not discuss everything in here. here we are going to discuss only about how we are going to use mode probe for insmoding a particular kernel module. And the third advantage, it supports the resolution of recursive module dependencies when required. Let's say when we request for insmoding a particular module X, if it has some dependencies on other modules, say Y, which again has dependencies on Z, modeprobe tries to find these modules in the standard lib directory and tries to resolve all the dependency symbols. These features are not available with the basic insmode command. We'll discuss more on these topics in upcoming slides. Now let's learn the difference between insmode and mode probe. What's the difference between insmode and mode probe? While loading a module, insmode fails with unresolved symbol error when an unresolved symbol is present in a loading module. Whereas in mode probe, it looks at the module to be loaded to see whether it references any symbols that are not currently defined in the kernel. If any such references are found, modeprobe looks for other modules in the current module search path that defines the relevant symbols. In short, while loading a module into kernel, if that module has any dependency on another module, modeprobe finds those modules from its search path. It loads them into the kernel. Note modeprobe is aware of the default location of modules and knows how to figure out the dependencies and load the modules in the right order. As I mentioned earlier, one more important point to note here is we need root permissions for executing both insmode and modeprobe commands. When a module is loaded, any symbol exported by the module becomes part of the kernel symbol tables. So what exactly is kernel symbol table? In earlier slides, we have discussed about insmode resolving undefined symbols by referring kernel symbol table. The kernel symbol table contains the addresses of global kernel items like functions and variables which are needed to implement modularized drivers. Now we know the details of loading the kernel module using insmode and modeprobe. Let's jump to our second topic. Our second topic in this session is listing modules currently loaded in kernel. We use a Linux utility called lsmode. lsmode command lists the modules currently loaded in the kernel. lsmode works by reading the proc modules virtual file. Information on the currently loaded modules can also be found in the sysfs virtual file system under /sys/modules. The syntax is very simple, it's just lsmode. Our third topic is unloading kernel modules. We have two kernel utilities to unload the modules. One is rmmode, the other is modeprobe. Let's learn about rmmode. rmmode is a Linux utility which unloads the loadable module. Module should be already loaded to execute the rmmode command. Module fails to unload if the kernel believes that the module is still in use or if the kernel has been configured to disallow module removal. Let's see the syntax of rmmode. The syntax is very simple. It's rmmode followed by the module name. So if you take the example, it's rmmode space my underscore module without KO extension. We need to be a super user for executing this command as well. So please make sure that you are a super user while loading and unloading the kernel module. Coming to the modeprobe syntax. Since we have already discussed about modeprobe in earlier slides, let's learn the syntax for unloading the kernel module using modeprobe. The syntax is modeprobe space -r followed by module name. For example, in order to unload my module, which is my underscore module, what I'll type is modeprobe space -r my underscore module. We have covered all our three topics for this session. One is loading the kernel modules, second is listing the kernel modules, and third is removing the kernel modules. We will wind up this session with an important question which usually people will face when they are attending an interview. You may face an interview question like, is it possible to forcefully remove the kernel module when they are in use? The answer is yes. It's possible to configure the kernel to allow forced removal of the modules even when they appear to be busy. So the commands normally used for removing a module forcefully after configuring the kernel is rmmode space -f, your module name. And if you want to use modeprobe, it should be like modeprobe space -rf and your module name. Configuration is config underscore module underscore force underscore unload. So this is the one which actually you need to enable or configure your kernel for forcefully removing a module when they are in use. Since we have already completed the theoretical part, let's go ahead with the practical part. We have already seen the usage of insmode command. We'll see how rmmode command is used for removing the module, and we'll also see the lsmode command for listing the module, and we'll see the modeprobe command for loading the modules, and we'll see how the modeprobe command is used for removing the kernel modules. First, let's list the kernel modules. I'll use lsmode command for this. I'll type lsmode command and I'll try to output this output using the pipe symbol, and I'll give a grep for hello. As you can see, we have hello.kvo which got insmoded in here. We saw that hello.init is initiated and we got hello world message when we type dmessage. Now we can see that hello is present in the kernel right now. Now just try using rmmode command. We know the syntax is rmmode hello without kernel object. I'll use dmessage command again to see the output of rmmode. As you can see, the dmessage displays goodbye cruel world, which is nothing but the exit command is called whenever we use rmmode command, and it displays goodbye cruel world. We have seen the ins mode, ls mode and rm mode. Now try to use the modeprobe command. Modeprobe syntax is modeprobe hello without any kvo, and I'll type enter. This complains a fatal error saying that could not open hello.kvo, which should be under modules directory, libmodules directory. So let's try to copy this from this place to libmodules to the kernel modules directory. Now try executing modeprobe. In order to avoid confusion, try to clear the dmessage. I'll give dmessage -c. When I type dmessage, there will be no messages left. Now I'll type modeprobe hello without any kvo extension. Now try using dmessage command. We can see that hello world is printed. Let's go ahead and remove the module. Modeprobe -r hello. Type dmessage. So we got goodbye cruel world. This is the way we can use modeprobe command for insmoding and removing the kernel object. Hope you enjoyed and learned something new in this tutorial. If you like this tutorial, don't forget to give it a thumbs up. To watch more videos, please subscribe Mr. Techpathy Tutorials. Thanks for watching. Goodbye for now.